Hello, everyone. It is Mr. Barden here. I'm coming at you with another P5 play video, and I'm wanting to show just a handful of useful things that we will be going over in my course, in the classroom, but are just very, very helpful in general. So the first thing will be one way to move the sprite around the canvas with keyboard inputs. I'm going to be doing that utilizing conditional statements in this video. I'm going to have a follow-up video about how we could do that with a switch statement. But it's kind of a whole other topic. I haven't really gone over switch in my videos yet, so I'm going to make that its own separate video that I'll record shortly after this one. Other than that, I'm going to be looking at some of the Sprite resources in the p5play website just to show how we can work out some basic physics and collisions, and then I'll have a third video about utilizing callback functions with those. So that's kind of what you can expect to be coming out over the next few days as I make all of them. I'll be recording all of them today, so you'll get to see me in the white t-shirt in my recliner on my laptop. This should be the final laptop in a chair video, but we'll see if people like it. I'll keep it up. I've got my desktop hooked up. I was just doing a lot of work on the laptop here, and I'm just trying to save time. So let's just hop right into it. Okay, so again, this is going to be a bunch of, a starting point for several codes. So I've got this one right here. We've got some stuff I won't really talk about in this video, but they will be important later on. I'll have this code in the description down below, so you can check that out. And if you need to kind of refresh yourself or learn a little bit more about how to utilize the p5play version 3 elements, check out some of the videos in my other playlists. If I've done it right, then up top the link to those videos should be popping up, and that playlist will also include this video, so you can just watch them all in order and be right back at this point. So if we run this, I've just got a sprite on the screen. It's always going to be this kind of bright pink color. I do just want to make it a little bit smaller, so maybe we'll make it 30 by 30 pixels, and there we go. Just as a quick review, again, this is how we implement, just making a sprite. If we give it, the X and Y location of the sprite's center, and then if you want a rectangle, you give it a width and a height. If you want a circle, you just give it a diameter for your third value. And then we can set the color utilizing the color property and the color function. So that's all that's right there. That's all I have in the code. Again, this sketch already has the p5play version 3 implemented. So if you don't know how to include that in your sketch, check out my video in the playlist. So what I've got down here is a function key pressed, and again, this just runs one time whenever you press a key. So if I click onto the canvas and hit a button, it will tell us what the value of the key code is. And I like to do this just because I don't always remember what my key codes are. So we'll implement that. W is 87, 65. A is 65. S is 83. S was 83, and D is 68. There we are. So again, I was just, clicking onto the canvas, hitting the key on the keyboard, and it would display this value right here. I like to implement this because I can manually say, okay, every time the D key gets pressed, we're going to do a thing. And it doesn't matter where the D key is on the keyboard, when it's pressed, it will still do that thing. So in order to move the sprites around, we're just going to do some basic conditional statements and be playing with the velocity properties of the sprite. So let's work that out. We can just going to go right down here, and we'll just say if key code is equal to 87, we're going to do a thing. Else if key code is equal to 65, we're going to do something else. And I'm just going to copy and paste this 3, 4, and change the number. So now we get 83 and 68. Now, since W is 87, generally in a 2D environment, when you press the W key, that's like the up movement. So we can just say player, that's the name of my sprite, dot velocity dot y equals -1. Because again, if you increase your y value, your sprite moves downward on the screen. So to move it up, then we have to set it to -1. I'm also going to set velocity.x to 0. The reason for this is because velocity has these two sub-properties of x and y, and that's just how fast the sprite is moving in the vertical and horizontal direction. Because these are separate values, if we only change one of them, any momentum, any movement and energy in one direction is still going to be kept. So if we're moving to the left and all of a sudden we start moving up, the sprite's going to keep that momentum and move diagonally. I just want my sprite to move up, down, left, and right. So whatever direction we're not moving, I'm setting that to 0. So I'm going to copy this and paste it down here. So A is 65. That's the left. So we'll set Y to 0. And we'll set X to -1. If I paste this, boop, we'll set Y to +1, X to 0 to move it down. And then we'll set Y to 0, X to 1 to move it to the right. I'm going to tidy that up because that looked real nasty. And I'm going to do W up, A, and left. Oop. S is down. D is right. There we go. And I'm just going to delete these comments up here just to help save some space. So now, just to break down exactly what's happening is we have every time the key is going to be pressed, it's going to display the key code. We don't really need that for the functionality, but it's nice to have. And then it's going to say, okay, if that key code is a value, it's going to set the velocity of the sprite and move it in the various directions. So if I refresh this, click into the sprite, and I move it up, our sprite moves up, down, left, and right. So again, just as a refresher, because the point 0, 0 is up here, right here, this corner of the screen. That's why, again, we have to move it down, we have to increase the Y value. To move it up, we have to decrease it. To move it left and right, again, that's increasing the X, moves it to the right of the screen. Decreasing it moves it towards the left. Notice, though, that as I hit other things, the sprite stops moving. So we can further encapsulate this just by adding a final else. If I paste that and just set both of them to 0. And I kind of like this because now I have to keep, pressing that. If I, press anything else, the sprite stops. So that way, if I hit any key that, hasn't been programmed on my keyboard, the sprite stops interacting. That way I don't potentially break something, and then I can just keep adding these else if key code equals blank and so on to set whatever. So again, I could play around with maybe making things jump or move around in different ways with other keys. But that's just how we make them move using a simple conditional statement. Again, I'll show you how you might be able to do it with a switch in a separate video. I think that's kind of a fun, slightly different way to do things. So there's the first part of that. What I want to talk about next is just how, sprites can have some basic physics applied to them. And this is very, very useful because, again, our sprites, they're going to be just living over the background. I guess doing it like that would make more sense for y'all. And so there's all these sprites in this plane of existence over the background, and they interact with each other in different ways. I've got right here part of the p5play website where they're showing several of these embedded things. So again, by default, sprites have some values, but you can set them to be different things. So there's this one right here with the dynamic versus static colliders. So right there. So if we were to just make another sprite, I'm going to use barrier here. Barrier is a new sprite. And we're just going to put it on the bottom of the screen like before. We'll just say 0, or no, it should be a width divided by 2. The middle of the screen. Height minus 25. I'll make it really wide and really narrow, just like before the other one there. And there is the sprite. If we bump into it, they do interact, but it might not be how you want it to. You'll notice that that momentum from the first sprite pushed and transferred into the second, which is useful, but we can set a few different things. So they all have a dynamic collision detector, as I've mentioned before, and that's what made the sprite move. So if they're static, the collider and all that, it can't be moved. But if and there's none, they just don't collide. So barrier dot collider equals static. You should see, assuming I spelled that right, bonk, it has bounced. But now that sprite on the floor, the barrier, instead of the momentum transferring and moving into that sprite, it has boink, bounced off. So this sprite down here is effectively immovable in terms of its collision data. So if you want to keep a sprite from moving, that's what we can do. Bonk. It's right there. Other than that, a very handy thing we can apply to our sprites is gravity. Okay, they don't have a separate one. It's just part of this. So what we can do is just set the gravity value right here to some amount. Basically, the higher amount you have, the faster, the more gravity there is. So if I just said, I'll just make some space here to keep all of my things together. Player.gravity equals 10. Well, then this will fall. What? Why doesn't this want to work? It literally pulled it out of here. Oh, it's because I have to say world.gravity. I always get that mixed up. So in previous versions of this library, you would be applying, gravity. You can manage it with a global thing, but you would essentially be applying it to the sprites individually. This is a new thing. And instead of the player, we're applying it to the same gravity to the whole scene. Essentially, that in p5 play is just referred to as the world. All right, so that's whatever is in here, the world. We can set the gravity, and things will fall. Again, I'm gonna have 10. If we want less gravity, it falls a lot slower than before. So again, we can set that to match whatever you want for your scene. Again, maybe you want things to fall very quickly versus not. That's up to you and what you want to do in your projects. But that's how we set that there. It's kind of hard to see right here, but I'll show you right here in this one is that you can set this to be, again, negative as well and have things float up. So again, you can set all of that. I'm curious to see if I set this to X, if it'll move to the left now. And it does. So again, you can set this in a horizontal or vertical fashion. Generally, you'll probably want the vertical one because, again, most time gravity moves down. But if for whatever reason you need something to pull your sprites, in any direction or any combination of things, you could set that manually just with the X and Y properties. So that's pretty handy. Bounciness is another one right here, and it's pretty self-explanatory. It just tells you how much of a bounce you'll have when things collide. So if I just said player dot bounciness equals 2, if I run this, boing, that's a lot. I'll put it back at 1. Anyway, and that kind of, I think it does that. So generally, at 1, it'll bounce, as high as it started with. So you can think of it as maybe 100% of the bounce height reached. In a lot of cases, you may have a slightly smaller one. Because in the real world, as things bounce, they don't bounce quite as high as they did last time. So now at this point, every bounce is 0.7 of the height of the previous one. If you want things to get bigger, like you saw with when I set it to 2, then that sprite would be bouncing twice the height it started from. And again, that's not necessarily how things work in the real world, but you're making a virtual environment, so you can make it be whatever you want. Again, if I like setting it to be less than 1 personally, just because that's a little bit more realistic, but that's up to you. Again, if you set the collider to none, then the sprites just don't interact, as you see there. The last thing I want to mention from this page is a very handy thing that was not possible in previous iterations of this library, and that is that the colliders will rotate to match the rotation of the sprite. So in this case, if I said barrier dot rotation equals, I don't know, I'll make it 10 degrees. Now it'll slope, but then boing, boing, it all collides and adapts with that as we want. Maybe I wanted to, make this a little higher. Boing, boing. And you can see that again, the sprite is bouncing off of the barrier, but it's moving with that same gravity, with that same slope right there. So we can set all of this to match up exactly what we need. We don't have to do any complex math or calculus in order to rotate colliders and set things. It all just matches with the sprite, and that is very, very handy. The last thing I want to talk about, if we hop into the next one, okay, so it's not in the next one. I always forget the order of this because it's still pretty new. But there's different ways we can move sprite around. Again, I've talked with the velocity a bit, but you can also do direction and speed, things like that. But what I'm wanting to do a bit more with are, not that one, Here we are, the collides, colliding, and collide-id methods. So the basically, whenever we collide two sprites together, you can tell I didn't script this. Whenever the sprites are colliding with each other, we can set things to happen. So there's a few different ways we can go about that. So in this one, it's pretty straightforward. But you can see here, the pillar is boing, 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 hanging like that. So we'll start with this first one right here, and let's just kind of break down the example. So we've got right here. So if the player, that's funny they named it the same thing I did for this example, if it collides with the pillar, we're going to do a thing. And that's what's going to happen right here. So let's use this again. And let's go into the draw function. So this is kind of the first thing, actually, for this unit that we're doing in the draw function. And the reason for that is because we want to keep checking that every frame. These are happening in the draw function and not the setup like the other stuff. So if we said if player dot collides with the barrier, then we can set things up. And again, this is just the name of the sprite or sprite group, and then the sprite or sprite group that they're interacting with. We'll talk about groups in a later video, but you can group together a bunch of sprites and just have the same interactions with them. But again, we can set whatever we want here. So maybe I want to say barrier dot color equals color. Maybe I'll make it I don't know, black instead. We can do that. I could say barrier dot rotation gets assigned. Actually, can I just say multiplies equals -1? So I just kind of picked this out randomly. And we'll see if it actually works. But basically, when the player collides with the barrier, the first time it'll change the barrier to black, but then we won't be able to see it change again. But then it will rotate, change that rotation of the barrier. So we should see it hop back and forth. And let's just see if it actually works. Boing. Yep, there we go. So we've got this happening. So again, every time one sprite is colliding with the barrier, it's changing. So an important distinction is that when it collides, that is going from not touching to touching. If they're still touching, that's not a new collision. The sprites have to separate by at least 1 pixel before they and touch again before that counts as a new collision. That's why now that things have kind of chilled out here, that things aren't changing. If I made it a circular sprite, we might see it still roll down off the side. So again, that is just collides. And then while it is colliding, then that's, when they're still touching, then we'll have something else happen. So if I hopped over here and said, if player dot colliding ding with barrier, then maybe we'll say I don't know, I'll use the same kind of thing. Player dot color equals, we'll turn this into a color, and I'll make it, I don't know, green. I'll just pick that, and then we'll make the sprite slightly bigger. Why not? Player dot width plus plus player dot height plus plus. There. So now let's just give it a shot. Boing. There we are. So again, every time the sprite stays colliding with there, it'll get a little bit bigger. Maybe I wanted to make it get smaller. Why not? You can change this and be whatever you need now that you know how to set properties. So again, while the sprite is colliding, it will do that. And this one, it finally swapped to too small, and they move past each other. So again, this could be whatever you want. The last one we have here is collided. And this is, as soon as they're no longer touching. So this one, well, let's see what we can do. I'm going to copy this, and we'll change colliding to collided. And now that when they're no longer touching, well, let's background to purple. Why not? That should change back at the beginning of the frame. Will this actually work? Yes, but it's very, very quick. So let's change that. Maybe we'll just say barrier.height plus plus instead. So now, whenever the sprites go from touching to not touching, the barrier will get a little taller. Hopefully this is nice and visible. It's getting thicker and thicker each time. As the other sprite gets smaller, and they're still rotating back and forth. And at this point, the sprite got too small and doesn't exist anymore. So those are the basic things I wanted to really focus on for today. Again, to really break them down, we can move a sprite with a conditional, and just mapping that to the key code variable is a very straightforward way to do it. That's how I personally usually do it. We can also set the colliders, and those can be dynamic or static, allowing the sprites to bounce off of each other, or push that somewhere else, however we want to do. And we can specify what happens whenever they collide with each other. So again, we've got that right there. And this is just a simple, if they're collided, do a thing. And this just returns true or false right there. There's a whole bunch of other things we can do if things are, overlapping, things of that nature. And I'm just going to use this to scroll through the last thing. Chain colliders, not necessarily what I want to go over, but that's handy. Same thing with polygon colliders. Custom draw. Yeah, I think that's just about it. So in this way, you could make essentially what's called a callback function. That's the very, very last things. We could just say, function, barrier flip. We can utilize that to say right here, and just do that. So now every time we can just say barrier flip. There were other ways to utilize these callback functions in previous versions of p5play. I need to do more, digging myself and see if they still work in kind of the same way. Oh, that's fun. But again, you can see that there's a lot of stuff that these sprites can do just with some basic info. So I'll talk more about callback functions in a separate video just because they've changed in p5play from what I've talked about in my previous one. So you can also expect that coming out before too long. I think at this point I'm pretty much just starting to ramble, so I hope this was helpful for you all. If you have any questions, comments, concerns, definitely put those down below. If you start making some things that you really like to, would like to show off in p5play, definitely put that in the comments as well. I love checking out what people can do. Lastly, if you enjoyed the video, definitely consider giving it a thumbs up and liking it and subscribing to the channel for more. That's going to be all from me, and I will see you all the next time that I see you. Bye.